All right, well, today is Thursday, getting closer and closer to coming back to school. I'm excited for that. I hope you're excited too. It'd be nice to just get back and see you guys and get you some help on the things that you're trying to work on. So today our section is 24.2, which is conditions for parallelograms. Remember, this is your symbol for parallelograms. If you don't have paper, you might want to go grab some, push pause, come back, and we'll get it. So today what we're trying to work on is trying to determine if we have a parallelogram or not. So if I draw any quadrilateral, so quadrilateral four-sided shapes, and if I say this is congruent to this, and this is congruent to this, is that shape a parallelogram? Well, based on yesterday's lesson, we said that if the opposite sides were congruent, then yes, we have a parallelogram. So yes, that is a parallelogram. Okay? Now, what about if you have this situation? So you have a quadrilateral again, where the two sets of opposite angles are congruent. Is that going to make this a parallelogram? Well, again, based on what we said yesterday, if we have opposite angles congruent, then yes, we have a parallelogram. Okay, you probably understand what's coming next. What about if I draw again a quadrilateral and I draw in the diagonals? Now, thinking about yesterday's lesson, can you remember what's true of the diagonals? Well, remember, the diagonals bisect each other. So if that's congruent to this and this is congruent to this, then yes, you have a parallelogram. Now, one of the theorems that we didn't talk about yesterday that's going to come up is this. So again, I'll do it in picture format for you. So let's say that you have a quadrilateral, okay? And one pair of opposite sides are parallel and congruent. So one pair of opposite sides are parallel and congruent, then you have a parallelogram. Then yes, parallelogram. Okay, so this is kind of a minimum requirement type theorem. Okay, that as long as you have opposite sides congruent and parallel, then yes, a parallelogram. Now, honestly, these are the ones that we probably will deal with the most and we'll think about the most. But again, this is kind of one of those side theorems there that we need to know as well. Okay? So let's do a couple of examples of this today. This is what you're going to see in today's assignment. Number one, if x equals 7 and y equals 4, is the quadrilateral a parallelogram? Okay, so I'm going to try to see if I have a parallelogram or not. So here's the picture we're going to have. Go ahead and draw it. I kind of stick to the generic picture here you're seeing over and over. I draw this kind of like I did with triangles, remember? This side is x plus 14. This side is 3x, that's the AD side at the bottom. Over here to the right, the CD side is 2y plus 8. And the AB side is going to be 5y minus 4. So again, we're trying to figure out if this is a parallelogram. Well, when we talk about the sides, what would we be looking for? We would be looking for the opposite sides to be congruent. So what they want you to do here is just substitute in. So I'll substitute in 7. 7 plus 14, that makes this side 21. 7 times 3 down here, 21. So far I'm looking good. I know that this side would now be congruent to that side. But again, I need the same thing here. Plug in the 4. 5 times 4 is 20 minus 4. This side is 16. 2 times 4 is 8. 8 plus 8 is also 16. So do we have a parallelogram? Well, if opposite sides are congruent in a quadrilateral, do you have a parallelogram? The answer is yes. Yes, the quadrilateral is a parallelogram. Okay, and we're good there. All right, let's try another example. Okay, so question 2. So question 2, again, same shape. Okay, quadrilateral, looks like it's a parallelogram. We don't know if it is. I'm going to tell you in this one that Z equals 11 and W equals 4.5. May want to push pause there and go grab a calculator. This angle down here at the bottom corner is going to be 11Z minus 3. Up here in this corner, this angle is going to be 14W minus 1. Again, those are degrees. Here we have 12W plus 8 degrees. And this top left-hand angle is going to be 9Z plus 19. All right. So let's do the ones with Z's. Those are a little bit easier to do without a calculator. We can grab a calculator for the others when we get there. So plugging in 11 here, you'd have 9 times 11. That's 99. 99 plus 19. Again, might still want your calculator out, so go ahead and grab that real quick if you haven't. So we're going to have 99 plus 19, and that comes out to this angle being 118 degrees. Okay, we'll do the same thing here. Plug in 11. 11 times 11 is 121. Minus 3 is also 118 degrees. Now for these two, we're going to have 12 times 4.5. Okay, and that's 54. 54 plus 8 is going to be 62. There. Do the same thing here. 14 times 4.5, hit equals, and subtract 1. That also is 62. Now, just kind of as a backtrack there for a second, we could have found this angle without plugging in 4.5. We could have subtracted from 360. The sum of the angles of a quadrilateral should be 360. But based on the theorems now, because the opposite angles are congruent, do we have a parallelogram? And the answer is yes. The quadrilateral is a parallelogram. Okay? Got to have that in order for it to work. Okay? Let's see. Last example here. Question number 3. We'll draw again what looks to be a parallelogram. Got your diagonals drawn in. This side here is 11y minus 6. Actually, that part of the diagonal. This part of the diagonal here is 4x minus 10. Here we have 6y minus 1. No, plus 1, sorry. And this here is 2x plus 2. And I'm again going to check to see that if x was 6 and y equals 3, would I have a parallelogram? So again, this is trying to demonstrate if the diagonals bisect each other, then we have a parallelogram. So let's start with 6. If I plug 6 in here, 2 times 6 is 12, plus 2 is 14. That makes that segment 14. If we plug in 6 here, 4 times 6 is 24, minus 10. This is also 14. So far, so good on diagonals bisecting each other. When I plug in 3 here, 6 times 3 is 18. 18 plus 1 is 19. And then we'll plug in 3 here. 11 times 3 is 33. 33 minus 6 is not 19. 33 minus 6 is going to be 27. Do we have diagonals that bisect each other? I thought I was looking good with both the 14s, but here, no. The diagonals do not bisect each other, so no, not a parallelogram. So again, remember, for a parallelogram, very quickly here before I have to go, the opposite sides are congruent. The opposite angles must be congruent. Obviously, the opposite sides should be parallel. And the diagonals are going to bisect each other. So we'll have 3 marks, 3 marks, 4 marks, 4 marks. Okay, so again, we've got our properties. Got to get it. Homework today is page 982. You're going to do 5 through 12, 14, 18, and 20. Okay, see you guys tomorrow. It's Friday, last day of our time off of school.